In this example, we're going to determine all 6 trigonometric ratios if tan of theta is negative 12 over 5 and theta is between 3 pi over 2 and 2 pi. The first thing we want to do is try to get at the point or try to determine our triangle. So I'm going to draw a right angle triangle in quadrant 4 because I know that theta is between 3 pi by 2 and 2 pi. So we know that we're really working with an angle down here in quadrant 4. Now next, let's use this information about tan of theta to try to help us determine this point here in quadrant 4. We know that tan of theta is opposite over adjacent, so that means we have 12 over 5. And if this point is in quadrant 3, that must mean it is the ordered pair 5 and negative 12. So I'm going to put my negative sign here with the number 12. And then we can use Pythagoras' theorem to try to get at the distance from this point to the origin, or the hypotenuse of this triangle. By Pythagoras' theorem, we know that h squared is equal to 5 squared plus negative 12 squared, or h squared is equal to 25 plus 144, which means that h squared must be equal to 169. And taking the square root of both sides, we have that the hypotenuse must be plus or minus 13, but since the hypotenuse is the distance from our point 5, negative 12 to the origin, we're going to take a positive measure of 13. Now that we have all 3 measures on our triangle, we should be able to determine all 6 trig ratios. Let's begin with cosine of theta. Cosine is adjacent over hypotenuse, so we get 5 over 13. Next up is sine theta. Sine theta is opposite over hypotenuse, and this is going to give us negative 12 over 13. We already know that tan is negative 12 over 5, so let's go ahead and fill that in. To fill in the remaining 3, we will use the fact that they are reciprocals of the existing ratios. So secant of theta is the reciprocal of cosine of theta, so here we get 13 over 5. For cosecant theta, we'll get negative 13 over 12, and for cotan of theta, we will get negative 5 over 12.